our next skill is to take a perfectly good vector component vector, and when we're all done doing all the calculations we need to do with it, and turn that vector into an angle magnitude vector. And this is what we typically do when we're all done with the problem. Okay? So, but I'm going to show it to you now because we've just done angle magnitude to vector component. Now we're going to do the opposite. Okay? And the good news is this. I'm going to show you how to do two more things today. But this is the only one of them that I have to explain in any detail. The other two are self-evident. Okay? So this is just a wonderful thing. Okay? So we are doing vector component to angle magnitude. And let's suppose we've got this vector that's 5.1 meters in the x, right? And negative 1.7 meters in the y. Why? Because we love you. Does anybody know where that's from? M-I-C-K-E-Y-M-O-U-S-E, right? And then don't they do this thing where they go through and then they end on Y and they go, why? Because we love you. Yes, don't they? Does anybody? Yeah. Anyway, look it up. Okay, so step one for this, and this is the hardest step, and I don't know why. I don't know why. If I knew why, I would be a good teacher because then I could say it's this way because of that thing you don't understand. Okay, so the first step is to draw the vector. These are the components of the vector, but the vector needs drawing. We must make a drawing of the vector. Okay, and so I always start with x and do y because I'm just very traditional. So I'm going to go over 5.1 and I'm going to go down 1.7. Now, did I measure that? No, but I made sure that the big component looked bigger than the small one. The second thing is that I placed the components tip to tail because we are adding those two vectors. And when you add vectors, the vectors are tip to tail. Yes? Just like your dog and some other dog. There we go. I know. Sorry about that. Okay, now the vector, let me draw the vector for you. Okay, the vector starts where the components started and ends where they ended. The vector does the same thing as the components. That's why they are the components of that vector. Yes? So, the vector does this. Don't worry that those guys are tip to tip. You know, that's okay. Because you're like, no, it's always tip to tail. No. The vector does the same thing as the components. This vector is to the right and down, isn't it? And these components are to the right and down, aren't they? You're all nodding your head, but when we go to draw these things, you're going to draw them randomly. You'll draw them tail to tail. Okay, I promise you. But anyway, that's okay. We'll weed you out and try to correct this behavior. Right now, basically, this is the only hard part. I just need to find this angle right here. Right? How do I find that angle? Yeah, just use trig and negative. I'm going to use negative tangent, I think, right? So the next step is find the angle. And if you're dyslexic, you could find the angel too, right? Okay. And then step 3, find the magnitude. Right? So the angle, I always use inverse tan. Tan minus 1 of opposite over adjacent is my angle. I'm using the TOA of SOHCAHTOA, right? So that's tan minus 1 in this case of 1.7 over 5.1. Now, I know some kids are going to say, why didn't you put the minus in there? And the answer is that I don't need to put the minus in there. Okay? I'm man enough to find an inverse tangent without putting a minus in there. The real answer to that is I don't know. I don't know why, but I never do because I never paid attention in math class. And I don't know what happens when you put the minus in there. I was a bad student. I'm sure it does something intelligent, but I steer away from that. Second tan. Okay, so that looks like, oh, my calculator turned itself off. Isn't that nice how this virtual calculator saves its virtual power? All right, clear. I'm trying to click clear, and I'm not clicking.
Oh, I think you need to press.
No, I don't think so. It is not clicking. Ah! Alrighty. I don't know. Let's just try reconnecting. I am reconnecting. I am reconnecting. I have very little patience for technology that does not work. I tried to return this thing to Fry's right after I bought it. Clear. All right. Virtual calculators are overrated. It's like Frozen, isn't it? It is.
It's running.
Yeah, it thinks it's running. It's not anymore, though. I'm able to click on other things. All right. Aha! Voila! Second tan of, whoops, 1.7. Yeah, there we go. Do you guys get 18.4 degrees? All right, the second thing, shh. I know it's exciting when the technology doesn't work, but it's not that exciting. So the second thing you do for this is you find the magnitude. I'm going to draw the magnitude up here. The magnitude of this thing is the square root of 5.1 squared plus 1.7 squared. Okay? Don't put the minus in this one either. It shouldn't matter, should it? But your calculator, in my opinion, does not evaluate this expression correctly. In my opinion, since it's a unary minus, it should be a positive number. But your calculator interprets this to be the opposite of 1.7 squared. So it evaluates the squared first and then makes, yeah, that doesn't make any sense. Okay? So don't put the minus signs in there when you do that. Do it in one swell foop, though. Go second square root 1.7 squared plus 5.1 squared. And that's 5.37. Yeah. And I know that we don't have that many sig figs, but that's all right. And these were meters, so we're good. Yeah.
If you put the negative in the tangents, it makes the final results negative.
Yeah, no, I never do that.
Is that bad?
Yeah, I think it's bad.
Useless.
That's why I don't do it.
Okay.
All right. So draw this vector, and then notice that I'm sort of clever here. I want you to draw it. I want you to show me the drawing, right? And then I want you to find the magnitude, and I want you to find the angle it forms with the x-axis. You can either find the x-axis angle or the y-axis angle. I want you to know, though, how to find whichever angle, right? Now, because I drew this to scale, I find it highly believable that that's 18.4 degrees. Yes? Now, if I'd gotten an angle like, oh, I don't know, 71.6 degrees for this, would I believe that?
Probably.
Yeah, I'm thinking you should be skeptical of that angle there is 71.6 degrees, correct? You would know that you got actually this angle, correct? By mistake? And you would reevaluate your thoughts about this, right? So here I'm just asking you to find the angle of the x-axis, which is exactly what we did here. Draw me a picture of this vector. Make sure on your vector that you labeled the vector itself. And I need that to be an arrow. I need you to show me which way that vector's going. Because I don't really believe that you understand.